Here we have a rectangle divided into 3 equal parts, and 2 out of 3 of the parts are shaded in. So to represent what part is shaded in, we would say we could represent it like this. 2 out of 3 parts shaded in, and this is read 2/3. So the fraction that's shaded in is 2/3. Here we have a large rectangle, and it's divided into 6 equal parts. 1, 2, 3, 4, 5, 6. And 2 out of 6 of the parts are shaded in. So to represent the shaded in portion, we would say 2 out of 6 shaded in. Now, this rectangle is also divided into 3 equal parts. The dark borders divide the rectangle into 3 equal parts. 1, 2, 3. And 1 out of 3 are shaded in. So we see from this example that 2 out of 6, the fraction 2 out of 6, or 2/6, is equal to the fraction 1/3. Both represent this shaded in area. So these are what we call equivalent fractions. Let's look at the fraction 5/5, or 5/5. 5/5 is equal to 1 because it represents all of the different parts, 5 out of 5 parts. So that's 100% of the parts, or 1. So if we have the same number over itself, a fraction which has the number on top equal to the number on bottom, then that fraction is equal to 1. Okay, let's look at this fraction, 2/3, just for some vocabulary. The number on top is called the numerator, and the number on bottom is the denominator. Now, if we multiply 2/3 by 1, of course, we get the same thing. Any number times 1 is equal to the number itself. So, and we said that 5/5 is equal to 1, 3/3 is equal to 1. So if we multiply 2/3 by, let's say, 4/4, 4/4 is equal to 1, we get the fraction multiplying across the top, we have 8. Multiplying across the bottom, we have 12, because that's how we multiply fractions. We'll actually see that later. The way we multiply fractions is by multiplying the numerators and denominators. So we have this fraction 8/12. Well, since we multiplied by 1, 8/12 must be equal to 2/3, because we multiplied 2/3 times 1, 4/4 is 1, in order to get 8/12. So these are equivalent fractions. They're equal in value. They look different, but they're equal in value, and we call them equivalent fractions. 2 fractions are equivalent fractions if we can get from one to the other by multiplying top and bottom, or numerator and denominator, by the same number, like we did here. Here we multiplied numerator denominator by 4 to obtain 8/12. Now let's say the fraction 3/4, and we want to obtain an equivalent fraction. Well, we could just multiply top and bottom by multiplying numerator denominator by the same number, and we could get an equivalent fraction. So 3 times 5, that's 15, and 4 times 5 is 20, and these two are equivalent. Now let's say we start with the fraction 2/3, and we want to find an equivalent fraction where the denominator is equal to, let's say, 21. Well, we say to ourselves, what do we multiply 3 by to get 21? Well, 3 times 7 is 21. So if we multiply the numerator by the same thing by 7 as well, we will get an equivalent fraction. 2 times 7 is 14, so this is an equivalent fraction. In this first example, we want to find an equivalent fraction whose denominator is equal to 15. Well, we have to multiply numerator and denominator by the same thing. So we say to ourselves that 5 times 3 is equal to 15. So if we multiply the numerator times 3, 2 times 3 is 6, we obtain 6 over 15. We obtain our equivalent fraction. In number 2, we want an equivalent fraction, something equivalent to 4/7, whose denominator is 35. So we say to ourselves, well, 7 times 5 is 35, so let's put the 5 over there. And so if we multiply the numerator by 5 as well, we'll get an equivalent fraction. 5 times 4 is 20. So here's our equivalent fraction. In number 3, we want a fraction equivalent to 3/4, whose numerator is 12. Well, let's see. If we multiply 3 times 4, we get 12. So let's multiply the denominator by 4 as well. 4 times 4 is 16. And here is our equivalent fraction. Here our instructions are to reduce to lowest terms. If we divide numerator and denominator of a fraction by the same number, then we are reducing the fraction. And if we reduce to lowest terms, that means that we divide by as much as possible until there is no other common divisor between the numerator and denominator. So let's start with, let's say, 12 over 48. And let's say we divide top and bottom by, let's start by dividing top and bottom, let's say by 2. If we divide 12 by 2, we have 6. And if we divide 48 by 2, we have 24. Okay, so this fraction is equal to 6 over 24. Now we can divide top and bottom now by 3, let's say. If we divide the numerator by 3, we have 2. And if we divide the denominator by 3, we have 8. So this fraction further reduces to 2 over 8. So far 12 over 14 has been reduced to 2 over 8. Now, can we still divide numerator and denominator by a number? Well, yes. Both are divisible by 2, so let's divide by 2. And finally, we have a fraction in lowest terms because there is nothing else that we can divide top and bottom by. So reduced to lowest terms, 12 over 48 is equal to 1 over 4. Now we could have done this in one shot if we realized that 12 over 48, that the numerator and denominator are both divisible by 12. We would have gotten the result right away. Or if not, we can always do it in a few steps. Okay, number 5, we have 4,000 in the numerator and in the denominator 6,400. Let's right away divide top and bottom by 10. And we can just indicate that by crossing off 2 matching zeros. And we can divide by 10 again. Again, indicate that by crossing off 2 matching zeros. So far we've reduced to 40 over 64. Now, maybe at this point, we'll divide top and bottom by 4. 4 into 40 is 10. And 4 into 64 is 16. So we've reduced our fraction to 10 over 16. Now numerator and denominator are both divisible by 2, so let's divide by 2. So here we have 5 and here we have 8. And we can no longer divide numerator and denominator by any number other than 1. So we have reduced to lowest terms. Okay, again, number 6, we have 42 over 54, and we want to reduce to lowest terms. Okay, we might notice that numerator and denominator are both divisible by 6. So divide by 6, here we get 7, and divide by 6, and here we get 9, 7 over 9. So we can no longer divide numerator and denominator by the same number except for 1, so we've reduced to lowest terms. Now, the number 3 and 5/8 is called a mixed number because it's a whole. The 3 is a whole number and the 5/8 is a fraction, so this is called a mixed number, wholes and fractions. And if we want to change this to a fraction, and I'll explain in a minute why it will be called an improper fraction. If we want to change this to a fraction, we'll have a simple way of doing this, but basically what we're doing is we're saying, well, 3 wholes is equal to 8 over 8 plus another 8 over 8 plus another 8 over 8. That's for the 3. And then we would add another 5 over 8. Okay? So to do this, we have a method for doing this, a simple method for figuring out how many eighths there are, how many 1/8 there are in 3 and 5/8. And the simple method is we take the denominator, multiply it by the whole, and add the numerator. All right, so this is equal to, let's keep that same 8. It's equal to 8 times 3 is 24, and add that numerator of 5, and we get the fraction 29 over 8. Now this is called an improper fraction because the numerator is larger than the denominator. So this represents more than one whole. 8 over 8 would be one whole, and if the numerator is bigger than 8, it represents more than one whole. So that's why it's called that's why this fraction, 29 over 8, is called an improper fraction. Again, if the numerator is larger than the denominator. And number 8, let's do that again. We'll do our little method for converting to an improper fraction. I'm going to use that same denominator 4, and we multiply denominator times the whole. 4 times 15 is 60, and add 1, and we have our improper fraction 61 over 4. Now here we want to go the other way. We have an improper fraction, 11 over 3, and we want to write this as a mixed number. So the way we do that is we divide the 3 into 11, and that'll be our whole. So 3 goes into 11 3 times. We have 2 left over. So our improper fraction is gotten by using this number to represent the whole part of the mixed number, and the remainder will be the numerator of the fraction. So we have 3 and 2/3. That's our mixed number. Again, you just divide the denominator into the numerator to get the whole, and the remainder over the denominator is the fraction. All right, let's look at this example. We want to write this as a mixed number, so we're going to divide 12 into 275 to find out how many whole numbers we have. So let's do that. 12 into 275. All right, 12 into 27 goes 2 times. And bring down the 5. And 12 into 35 goes 2 times. And here we have a remainder of 11. So we have 22 will be the whole part of our mixed number, and use 11 for the numerator of the fraction. So here's our mixed number. 22 and 11/12 is equal to this improper fraction.